Okay, so today I'm going to be talking about high resolution urban emissions mapping. So we do know that hyperlocal observations are great. They tell us a lot about how concentrations vary in space and help us refine our understanding of exposures. But they really fail at making us understand of what's actually impacting whom, and that's where emissions can help us a lot. But again, emission inventories in general are flawed and missing a lot of pieces. So what we're doing here is, for step one, we're integrating two different hyperlocal measurement paradigms to build up a spatio-temporally dense observational constraint. We combine that with an a priori set of emissions and an inversion framework that we developed called INFER to come up with posterior or corrected emissions which align really well with what's truly observed. Now, once we start looking into what do we get out of these posterior or corrected emissions, one cool thing that we saw was these sector-specific emission insights. We essentially were able to uncover neighborhood scale sources which were missing in the emissions inventory to begin with, really point out of sites which are true on the ground but were missing in the prior estimates. But also we were able to precisely attribute exposures, again in an observationally constrained manner. We picked up a particular neighborhood downwind of most of the emissions and we traced back of what's actually impacting the neighborhood, and we were able to precisely at a pixel level see of what impacts concentrations there. And this actually enables us to have a lot of targeted mitigation strategies in the future of what happens if I reduce this pixel and what happens if I reduce another pixel in assessing exposures and concentrations in one target receptor. Thank you.